Hello, my name is METİN Arıdaşır. This is 114th part of explanation of my theory. Your Schrödinger equation cannot do this. Arıdaşır, I predicted multi-electron helium's spectral lines wholly, exactly. Here, left side, NIST, National Institute of Standard Technology, NIST data, left side. Right side, my prediction. Compare two of these columns. Helium's spectral lines. Helium spectrum line. NIST data, left side. My prediction and computation, right side. Okay. Here. Left side NIST data, right side my prediction. Here, left side NIST data, right side my prediction. Here. Yes. Now. First page. Here. Snapshot. Then here. Okay. According to my theory and my formulas. 1. Starting point to determine spectral values of an atom is to know its initial wavelengths of proton-bound electron motion forms, p-bound electron motion forms. I advise you to watch my previous video. In fact, all of my videos step by step. 2. Each proton can make joint motion cyclical motion with Each proton can make joint cyclical motion with only one electron motion form. There is only one electron per proton in a multi-electron atom. There is only one p-bound electron motion form, proton-bound electron motion form per proton in a multi-electron atom. 3. There are no same wavelength size p-bound. There are no same wavelength size proton-bound free electron motion forms in a multi-electron atom. There are no same wavelength size electron in a multi-electron atom. There is no mixed same size electron soup in an atom. 4. For example, helium has 2 protons. Now, red circles are protons connected. There are 2 protons have made joint motion together. Red lines. Left 2 of one proton, left to right 2 of the other proton. Okay. One of upside, another downside. And this blue circle is smaller wavelength, 22.8 nanometer, initial in balance wavelength, smaller wavelength of helium, left side, upside, say here. Relatively this downside, green, greater, another electron motion form, proton-bound electron motion form. Its initial wavelength is lambda n 50.41 nanometer. Here in balance, not disturbed helium atom, according to my theory and my formulas. Multi-electron atom, one electron downside, another upside. There can not be same wavelength size electron motion forms in a multi-electron atom. Okay. This is so important for me. For example, helium has 2 protons. Therefore, it has 2 different wavelength size electrons. 2 different wavelength size electron motion forms. Proton-bounded electron motion forms. Smaller one is 22.8 nanometer. Greater one is 50.41 nanometer. How did I find 22.8 nanometer? I'm so sorry. How did I find 22.8 nanometer and 50.41 nanometer? Yes, how did I find 22.8 nanometer and 50.41 nanometer? 22.8 nanometer corresponds to 24.5 electron volt ionization energy and 50.41 nanometer corresponds to 54.4 electron volt ionization energy for helium atom. Yes. Yes. Lambda n smaller one, 22.8 nanometer. The other, lambda n, nanometer. Yes. 24 point eV ionization energy. Another one, corresponds 54 point eV ionization energy. Yes, here. 22.8 nanometer smaller electrons wavelength is smaller wavelength electron corresponds 24.587 electron volt ionization energy, and greater wavelength electron 50.41 nanometer corresponds 54.417 electron volt ionization energy in helium. Important. Each different ionization energy value in an atom represents a different wavelength size electron's wavelength, proton-bounded electron motion forms wavelength. Thus, there are two different size proton-bounded electron motion form in helium atom. One of wavelength is 22.8 nanometer, smaller one, and the other's wavelength is 50.41 nanometer. 6. Each different size proton-bound electron motion form in a multi-electron atom gives peculiar and exact response differently depending on their sizes to the same effects of free electron motion forms, effective successive waves. Here, a free electron motion form, say, its first cycle, its second cycle, successive waves, and second cycle comes in here. It affects smaller and make it enlarge here. If its wavelength is convenient size, it can affect this greater one. Then greater ones response will be different, smaller ones response will be different. And extend this for atoms, different wavelengths, and their lines will be different, characteristic lines. I mean, yes. Each different size p-bound electron motion form in a multi-electron atom gives peculiar and exact response differently depending on their sizes to the same effects of free electron motion forms, successive waves. 7. E equal to n multiplied by HF. This is wrong. Yes. This is my formula. This is true formula. Okay? Here. for computing energy of an atom or electron motion form or electron. Here. Okay. I hope you see. N is equal 1 for proton-bounded electron motion form, and delta lambda is equal to 0. Electron motion form, proton-bounded electron motion form, stable, we think of in an atom, and delta lambda is equal to 0, then n equal to 1, and then here, divided by n squared. It means photon follows inverse square law also. Here, Einstein and Einsteinian theories, Einstein's theory is wrong. In accepted physics, according to Einstein and the others' opinion, theory, in accepted physics theories, the photon doesn't follow inverse square law, but inverse square law is intrinsically here. In the photon or light successive waves, okay, follow inverse square law also. 8. Here, quantum theory used Rydberg formula. Here, ghost formula, I say, this one. Okay. Rydberg formula used by quantum theory is the ghost and wrong formula in accepted physics. Finally, you cannot solve multi-electron atoms' spectral lines by using Schrödinger equations. This is impossible. You cannot predict. Finally, for example, here a free electron motion form. It produces and propagates successive wave. This is its first cycle, and second cycle come in, connected with smaller wavelength size of helium atoms, smaller wavelength size electron of helium atom connected, and this successive wave, second successive wave, n equal to 2, affect this electron motion form, proton-bounded electron motion form, and this second successive wave make this electron inflate as a balloon. Okay, not same thing. And at the rate of n squared, here, what was smaller electron motion form's initial wavelength? It is lambda n1 is equal to 22.8 nanometer. Then n square lambda, this second successive wave make small electron enlarge to 91.2 at the rate of wave number square. Okay, you see, obviously. Then When this effect vanishes, it shrinks its old normal original wavelength again. While doing this, okay, this small electron motion form produce and push single wave pulse as a sphere through the eternity, enlarging at the speed of light. Single wave pulse. I say this single wave pulse. Different light type differ from successive waves of free electron motion form. It is source of line spectra, characteristic spectra. Free electron motion forms, successive waves are source of continuous spectrum if free electron motion form relocates. Yes, then enlarged point energy. Here, and initial wavelength point energy. Difference is single wave pulse energy, and it represented by lambda wavelength. This is the way. Here you see obviously difference between these two point energies. One of here in this example, for this example, smaller electrons initial wavelength point at any point energy, and another enlarged point energy. What is difference? Because again, in this example, from this enlarged and dropped energy and come in again, it comes in again at this point, return energy. Okay, this is formula. From this energy minus this energy is equal to, we use here 22.8, remember, 22.8 nanometer. Lambda, we use wavelength in here. In accepted physics, they don't use different wavelengths. Okay. Then I found difference of 2 points energy, and here 40.76 electron volt difference between 2 points energy, and it corresponds this wavelength, single wave pulse wavelength. Representative wavelength is equal to divided by 30.41 nanometer for n equal 2 to n equal 1. Go back. What was it? We look now. Here. This is. And left side NIST data, right side my prediction. Okay? Yes. And snapshot.